Howdy doody, kiddos. All right, we're going to talk about some area. A lot of this is probably going to be a review from 6th grade, and the last example that I give you today will probably tie all of that in. So yeah, let's get started. All right, so we are trying to find the area of some basic shapes. I've got my star chart here, and this one shows the area for triangle, rectangle, or parallelogram, trapezoid, circle, and it's missing square on here, but we can figure that one out based off the rectangle and parallelogram one. So if you need to write any of these down, please feel free to, but I'll also write them down as we go. All right, so when we start off with a square, we know that all four sides are the exact same size, exact same length. Everything about them is the exact same. So this one's actually pretty easy. Oh, sorry, y'all. It's a little bit wobbly. Let's see if this will help. There we go. And the formula for a square is going to be area equals base times height. Now notice on my square, however, I don't have any side links. So I'm going to kind of make them up as we go. And if I leave anything off, feel free to leave me some complaints and I'll try to fix them for next time. So I'm going to say that this side length is 6, which means that every single side on this square is also 6. These little markings that I put right here are just showing me that they're all equal, they're congruent. And so for the formula, we're going to do area equals 6 times 6. And therefore the area of this square is going to be 36. And just to remind everybody, the area is the amount of something on the inside. Perimeter is the outside, but area is on the inside. All right, number 2, we've got a rectangle here. Notice that the two markings on this side show that these two are congruent and that these two are congruent as well. Formula for this is area equals base times height. Once again, over here, we're going to have, I don't know, we'll say this side is 8, and we'll say that this side is 2.5, 8 and 2.5. So I'm gonna have area equals, the base is 8 and the height is 2.5. It doesn't really matter which side is the base and which side is the height. They all go together. And I just got to multiply these out. So 2.5 times 8. Okay, and then I've got one number behind it. So the area or the inside of this rectangle is going to be 20. All right, easy enough. Cool beans. Let's get on to a parallelogram. So once again, a parallelogram is your base times height. Now I want to make something very, very, very clear to you. Ladies and gentlemen, this is not your height. This is not your height. This is what we call slant height. You'll see this a lot more in probably Algebra 2, so you got a good ways to go until then. Whenever we are finding the height of a figure, the height must form a 90-degree angle. It must be straight up or down. I know I talked about this with my students in class, but when you go to the doctor, you don't ever slouch down when you take your height. You stand up super tall, shoulders back, stick your neck out until your head's about to pop off, and you're just trying so hard to get that extra inch or two. So we want to be straight up and down. So I'm going to say that this one right here, we're going to say this is 11. Then we're going to say that this, my base over here is 5. I know those don't look like, it looks like this one should be longer, but just take my word on it. And then we'll say this is 2 and this is 2. Once again, y'all, these 2's don't matter. The formula for a parallelogram is area equals base times height. So it's going to be area is equal to 11 times 5. So the area of this parallelogram is going to be 55. So everything on the inside of this parallelogram is 55. All right, moving right along to a trapezoid. Now this trapezoid is a new formula that we're going to be using. And if you can see, it's going to be area equals 1/2 times base 1 plus base 2 times your height. I want to remind you that when you have parentheses, you have to do what's inside of there first. So before we do any of our math here, we're going to have to add our two bases together. So just be aware of that. All right, so back to my trapezoid. Again, I'm going to make up some numbers here. We're going to say this is 13.5. This will be 6.5. This is going to be 7. And this is going to be 8. All right. Now, once again, y'all, I just want to clearly express this. The height has to form a 90-degree angle. There's literally an H already on this picture for us, okay? Also, your bases have to be parallel lines. So these two right here are parallel. That's how I know these are my bases. These two lines, if I were to keep going, are eventually going to cross, which means that they're not parallel, so they cannot be my bases, okay? So for the formula, we're going to have area equals 1/2 parentheses B1 plus B2 parentheses times height. If you don't like fractions, you're more than welcome to put a 0.5 there or a 5/10. I'm good with that. Parentheses 6.5 plus 13.5 times the height of 8. So I'll kind of leave that there for a second so you can kind of process where all those numbers came from. As I mentioned a few minutes ago, we're going to add up all of our parentheses first. So we're going to have 13.5 plus 6.5. It's going to give me 10. That's going to give me smack dab 20. So I'm going to have area is equal to 0.5 times 20 times 8. Okay. I'm hoping that you understand that anytime we multiply a number by a half, it just cuts it in half. So 0.5 times 20 is going to give me 10. And now I've got 10 times 8. And finally, the area of that trapezoid, all of that on the inside, is going to equal 80. Cool, cool, cool. All right, triangles. You guys have spent some time with triangles last unit when we were talking about the angle measures. Well, now we're not talking about angles, y'all. We're going to be talking about the actual side length. So I'm going to go ahead and write in all my side lengths, and then I'll explain to you where to go from there. Let's call this one 5, 6, and 4. I'm just making them up again. The formula for this, based off the star chart right here on triangle, is area equals 1/2 BH. Area equals 1/2 BH. Area equals 1/2 BH. And from there, I just have to do a little bit of work. So we're going to keep our half the same. Again, you could use 0.5 if you wanted. The base is going to be 4. And I know so many of you are so tempted to tell me that the height is 6 because it's the biggest number. You're wrong. Don't do that. If Coach Carter or Miss Deeg tells you to do that, they're wrong too, and make sure you call them out. We don't want anything that has to do with slant height. Always real height. So this one right here forms a right angle, therefore it's going to be a 5. Okay, so half of 4 is 2. And I got to multiply that by my 5. The area or the inside of this triangle, ladies and gentlemen, is going to be 10. You guys are doing phenomenal so far. I'm assuming. I really don't know what you're doing. You could be getting all of them wrong, but I'm going to tell myself you're doing a good job. All right, this next one. This is part of a circle. It is not a full circle. It is a half circle. But in order to find the area of a circle, we must use what we're given. The formula for a circle is area equals pi r squared. And so what we're going to do is we're going to find the area of this entire circle, this imaginary other half of the circle. Hey, I didn't do too bad there. Looks pretty good. Okay, and then once we've found the area of this circle, then we're going to cut it in half because we're only given half of the circle there. So I'm going to scoot over a little bit so I have plenty of room. So we're going to have area equals pi r squared. In case you've forgotten from class, pi stands for 3.14. Radius, r. Radius is half of the diameter, not the diameter. I don't know what that word is. Okay, so radius is going to be from here all the way over here. Diameter is all the way across. Radius is just part of that. So let's say that my diameter is, let's say diameter's 10. I like that nice, easy number. Okay. Well, if I'm looking at radius, I'm not looking at the entire distance across the circle. I'm only looking for half of it. So the radius is going to be 5. Okay. So it's going to be 5 squared. So now I'm going to have area equals 3.14 times 25. Remember, ladies and gentlemen, that when we square a number, it is not 5 times 2. It is 5 times itself. I'm going to do a little cheating on my math here real quick just to keep this video shorter. And when I do that, I end up with area is equal to 78.5. Now, if that was the entire circle, then I would be good. But because I only have half of my circle here, I need to divide this number by 2 because I'm going to have half of it. So again, I'm going to cheat, use my calculator, and I'm going to find that area is equal to 39.25. So again, all this already shaded in area would be 39.25. Cool beans, flip it over. I think I got 2 more for you, y'all. Thank you for being patient, staying with me. I know there's nothing more you'd rather be doing than watching some dude talk about math, so congrats. Okay, right here. This is a very large quarter circle, okay? Again, I'm going to try to just draw a brief idea to show you what this would look like. Come back around. Okay, so you got to use your imagination a little bit, but that's a circle, okay? And again, it's not giving us the full circle. It's only giving us a quarter of it, so therefore we need to figure out the area of the full circle, and then we'll divide it by 4 to find the actual quarter. So once again, the formula is area equals pi r squared. Pi is going to be 3.14. If I were to give you this length, since I'm only showing you a quarter of it right here, this is my radius because the other half, the diameter, would be going this way. So we'll call the radius, we'll call it 3. Let's keep some numbers pretty good. And so we're going to have 3.14. My radius is 3, and I've got to square that number. So 3 squared It's going to become 3.14 times 9. Again, I'm going to cheat. I know it's going to be somewhere close to 27, but not exactly because of the decimal there. And I'm going to get area equals 28.26. But hold your horses there. We got to take care of this number. We're only talking about a quarter of the circle, not the full thing. So I'm going to divide it by 4. Divide that by 4. And I'm going to find that the area of this quarter circle is 7.065. Okay? All right, y'all. This is what we're working towards. Excuse me. What I want you to do is this is going to be one of the questions on your test. I just want to kind of briefly talk about it. This is what we call a complex figure. And the reason we call it that is because it's multiple shapes put into one. It tells you a drawing of a sailboat, if you say so, was made using a rectangle and 2 right triangles. Triangle 1, triangle 2, and your rectangle. What I want you to do is I want you to take some time on this problem, find the area of each individual piece, and then you're going to add it all together to find the area of the entire piece. That's what we're trying to master here, y'all. So just try it out. We'll see how it goes. We'll see where we need to pick up and where we need to explain some things better. Have a wonderful night. We're really proud of all of you guys. Thank you for just trying your best at what you do. Get some good rest tonight, eat a good breakfast, and we will see you bright and early tomorrow morning.